For decades, the relational database was the undisputed king of the software world. If you were building an application, you used SQL. It was structured, reliable, and predictable. Think of it like a massive, perfectly organized filing cabinet. Every piece of data had a specific folder, and every folder had a specific slot. This worked beautifully for financial systems and inventory management, where the rules of the data were set in stone. However, as we entered the early 2000s, the digital landscape began to shift in ways no one predicted. The volume of data was about to explode, and the rigid walls of the relational model were starting to crack under the pressure. This is where our story begins.
Then came Web 2.0. Suddenly, we weren't just reading static pages, we were generating content. Social media, blogs, and real-time interactions meant that data was no longer just rows in a ledger. It was messy, unpredictable, and massive. Companies like Google and Amazon realized that their relational databases couldn't keep up with the sheer velocity of incoming information. Imagine a fire hose of data trying to fit into a tiny funnel. If 1,000 users join your site every second and each one has a different profile structure, a rigid schema becomes a bottleneck. The one-size-fits-all approach of SQL was failing the needs of the modern internet. We needed something more flexible.
To handle more data, SQL typically scales vertically, which means buying a bigger, more expensive server. But there is a physical limit to how big one computer can get. NoSQL introduced horizontal scaling. Instead of one giant machine, you spread the data across hundreds or thousands of smaller, cheaper commodity servers. This distributed approach allowed companies to grow infinitely. If you need more power, you just add another node to the cluster. It's like adding more lanes to a highway instead of trying to build a faster car. This shift in architecture was a fundamental reason why NoSQL became the backbone of the modern web.
Another reason NoSQL exists is the schemaless nature. In a traditional database, you must define your columns and data types before you ever insert a single row. If you want to add a middle name field to a table with 1 billion records, the database might lock up for hours. NoSQL, specifically document stores like MongoDB, allows you to just save the data. Each record can have different fields. This agility is a godsend for developers who are iterating quickly. You can change your data model on the fly without a complex migration process. It's about speed and developer productivity. But there is no free lunch. Eric Brewer's CAP theorem explains the trade-offs. It states that in a distributed system, you can only have 2 out of 3: consistency, availability, and partition tolerance. Traditional databases prioritize consistency. Every user sees the same data at the exact same time. But in a global system, you might prioritize availability. This means even if one server is down, the system stays up, even if some users see slightly older data for a few seconds. NoSQL gave architects the freedom to choose the trade-off that matched their specific business needs.